Hi everybody! Today we will talk about the atom mass. Last time we talked about the structure of the periodic table and the atomic numbers. But in most figures showing the periodic table, more details are given. One information is the atom mass. But how can this be described? Already when talking about Rutherford, we discussed that most of the mass is in the atomic nucleus, and that the mass of the electrons can be neglected. So the mass consists of protons and neutrons in the atomic nucleus. Unfortunately, we cannot just weigh atoms. This is why we work with relative atomic masses, because we can determine the relative weights of the atoms compared to other atoms. This leads to the arbitrarily chosen Unified Atomic Mass Unit, or short U. First, this unit was based on the hydrogen atom, which was defined with a mass of 1 U, leading to protons and neutrons having a mass of about 1 U. Now, however, the atom mass is defined as a twelfth of the carbon atom, which has 6 protons and 6 neutrons in its nucleus. So the entire atom has a mass of exactly 12 U. So that's it? This is all? No, it's not that simple. We just said that the carbon atom has a mass of 12 U. Let's check what it says in the periodic table. Here it says 12.011 U, but we just defined the carbon atom's mass as 12 U, didn't we? Well, no, we actually didn't. We defined the mass of C12 as 12 U. C12 is a carbon atom with 6 protons and 6 neutrons. All atoms with 6 protons are carbon atoms, but the number of neutrons can differ. Atoms that are only distinguished by their number of neutrons are called isotopes. Their chemical characteristics can usually not be distinguished. Carbon has two main natural isotopes. One we just talked about, C12. Here you see how it is usually represented. The upper number is the number of nucleons, meaning protons and neutrons together. The lower number is the number of protons. In natural carbon, this isotope makes up for 98.9% of all carbon atoms. C13 makes up for 1.1% of all carbon atoms. As you can see here, it has 13 nucleons, meaning it has 7 neutrons in addition to its 6 protons. Its atom mass is 13.003 U. But how do we calculate the mass given in the periodic table? The mass is calculated with the isotope's weight and natural abundance. Let's go through this step by step. The share of C12 is calculated with its mass 12 U and its abundance 0.989. The share of C13 is then calculated with its mass 13.003 U and abundance of 0.011. This adds up to 12.011 U, which is also the information given in the periodic table. The atomic mass given in the periodic table is therefore the weighted average of all natural isotopes of an element. But why do I keep saying natural? This has two reasons. First of all, we are able to produce isotope-enriched substances, in which we do not have the natural abundance. Second, we are able to produce additional non-natural isotopes. In theory, one could imagine an infinite number of isotopes, the respective number of protons, and an infinite possibility for the number of neutrons. But we cannot produce all those possibilities, and even less occur naturally. For carbon, there's one additional natural isotope, C14, which is only found in really small amounts and is not stable but disintegrates. Additionally, we can produce the isotopes C10, C11, C15, and C16, but these are even more unstable than C14 and decay much faster. So, you see, there's not an infinite number of possibilities, but rather a really small number of isotopes, and the artificial ones are not stable. This was a more detailed look into isotopes and the atom mass as given in the periodic table. If you have questions, suggestions, or tips, leave them down in the comments. If you liked the video, like it and subscribe to my channel. See you in the next one.